Good morning, everyone, and happy Monday. Hope everyone's doing well. Today we are going to continue where we left off last week. I know because of testing and things and the half day, last week was a little all over the place. So this week we will continue on from there. So we're going to continue talking about scatter plots. And to start, take a minute and let me know, again, explain in your own words. Again, you can answer this right in this PowerPoint on the Google Slides. I'm explaining in your own words how you would use the slope-intercept equation to graph y equals negative 4x minus 2. So I'll give you a minute or so to think about that. Again, you're just going to type out what you would use, what you would do, what you would identify to graph that equation. All right, so here's what I said. Again, when we look at slope-intercept form, we always know that the slope is the m value. That is what is attached to the x. So that is negative 4 in this case, and our y-intercept is whatever is added or subtracted. So here we have minus 2. So if I was going to graph this equation, I would start at my y-intercept of negative 2, and then I would do rise over run for the slope, which is negative 4 or negative 4 over 1. So again, start at the y-intercept and then go down 4 because it's negative 4 and over 1 to put my second point, and then just connect them. So hopefully you said something like that. Again, that's just a review from the first unit, and we're going to move forward into creating the line of best fit and then creating the equation for the line of best fit later on. But today we have 3 objectives. We're going to read and create scatter plots. You will identify positive and negative relationships or correlations. And then again, you're going to draw the line of best fits. So if we look at the first example, this is a scatter plot. There's a bunch that we're going to just talk about. And this, again, if you look at our axes and the title, we're comparing the time spent studying with the actual score people got on the test. And it makes sense. And if we think about this, it is rising and makes sense if you think about it, right? The longer or the more time you spend studying, typically the higher the score is that you will get. Again, that's not always the case, but in general, that's how it works. Again, the title is always at the top in the middle. The key there tells you what each dot is meaning. So those are the test scores. And the axes are labeled there. Our x-axis is always on the bottom there, and the y-axis is always going up and down. So if we think about this, take a minute and see if you can tell me what was the highest score in the class. And again, you can click right on the Google Slide presentation and put your answer in right next to that. It should be there for you to click and add the score. And if you do that, you should notice that our highest score is this point right here that I've just circled in yellow, which is on the line for 95. So 95% was the highest score on this test. How many students studied for 1 hour? So again, hours is on our x-axis down here. So at 1 hour would be this line right here. So we need to see how many people are on that line for 1 hour. So there was 1, 2, 3, 4. So that means that 4 people studied for a total of 1 hour. And then how many students scored above a 75%? So that means we have to find our 75% line and then count all of the dots above 75%. So there is the line of 75%. And if we look at it, all of those dots are above 75. So all of those dots would be counted for this answer, which is a total of 12 students that scored above a 75%. So I'll leave this up for a couple seconds just to make sure you had those 30, 95%, 4, and 12 for the 3 answers there. All right. So now we're talking about the times that an individual spent at the mall or individuals and how much money was left in their wallet or bank account. So typically, the more time you spend shopping, probably the more stuff you buy. Again, that's the case for this situation, but not always the case. So if we graph this, we start with our axes. Time will always go on the x-axis if that is involved. And in this case, money will be going up on the y-axis. So 200 will be at the top, or 250 here. Again, that is the amount of money, and time in hours. So that is how you should put those on your axes. And then we have a dot at 1 and 200. So we'd put that dot in. We have a dot at 3 and 155, 4 and 145, and so on. So if we put all those dots in the scatter plot, again, there's our first dot, 1 and 200. You'll get something that looks like this. And if you remember back from our quiz on Friday, if we talk about this scatter plot, it is decreasing. So again, that is a negative correlation. Again, as time passes, the amount of money that is left decreases. This person continues to spend money, and it is continuing in a negative way. Till again, at 9 hours, I only have $5 left if you look at that. So here is how you create a scatter plot. So again, you have to choose good starting and ending points on each axis. You have to choose sensible scales. So if we go back, our scale is the amount you're going up by on your axis. So if we look at the money here, you don't just put 5, 80, 85, 145, 155, 200. That's something I see mistakes on whenever we are graphing. You have to go by a pattern. So if we look at our y-axis here again, and again, this is our y-axis I'm talking about, we have to choose an appropriate scale or an appropriate pattern. So this would be going up by 50s. Again, they did that because it goes from 5 to 200. So 50 is a reasonable scale for that. The x-axis as well is not by going by a pattern. So we can't put 1, 3, 4, 7, 8, 9. We have to go by a pattern. So in this case, on the x-axis, we went by 2s because it goes from 0 or 1 to 9, I should say. So those are why those were there on the axes. And again, that's what this is talking about by choose sensible scales. And then number 3, just a tip, time always goes on the x-axis. If that is involved, the time will always be on the x-axis. So your job now is to create a scatter plot for this. So it's already on the next page. All you have to do is add the points for the x, again, time's involved, so this will be our x-axis, and the y-axis. If you think about it, the time goes from 1 to 9, so I would again maybe go by 2s. And the money earned goes from 8 to 85. So if I were you, I would go from 0 to maybe 90 or 100 and go by 10s probably to get that all fit on your y-axis. So take some time and do that, and then we will talk about that one. And then again, the second one here is similar. This one talks about the age of a car and its value. And you're going to graph both of these or create 2 scatter plots to represent these. So go ahead and create those 2 scatter plots. I'll give you some time, and then we'll come back and discuss them. Again, make sure you label your axes. Make sure you pick appropriate scales. All right, so if we continue on, we're going to talk about some definitions now. A lot of people did not get these correct. Some people didn't on the quiz last week. And again, that is largely because we had the test and then we had some independent asynchronous work. So let's just touch on these things. So if there is a positive relationship or slope, then that means that it is increasing from left to right here, just like this one, or going up from left to right. This is a positive relationship. Again, if it is increasing, we consider this a positive relationship or a positive correlation. And again, if we drew a line of best fit here, it would increase from left to right and probably look something like this. Again, that might not be perfect, but again, that is what it would look like if we drew a line of best fit for this. And an example would be driving time and distance, right? The longer you drive, the further the distance. That would be a positive increasing relationship. We think about a decreasing relationship. It's the opposite of the last one. So this is a negative relationship. We would have a negative slope or a negative correlation because it is going down. And again, if we drew our line of best fit, it would be going downwards like this. Again, negative, it's going down from left to right. And again, if we think of a situation that could be represented by that, time and the amount of gas left, right? So the further we drive, the less gas that would be left in our tank until we hit empty and then probably have to fill up again. Then the third one, no relationship. I saw a lot of people put no relationship for some of those that were positive and negative. If there doesn't have to be perfectly in a line to be a positive linear correlation or relationship or a negative linear correlation. It's no relationship if the points are so spread out that you couldn't even put a line of best fit here. I have no idea what it would be. This is spread all over the place. And again, hair color and grades would be on, right? There's no correlation between that. Blonde individuals or individuals with dark hair don't score better or worse than anyone else. That's totally random. So the graph isn't positive, negative, not nonlinear. It is no relationship or no correlation there. And then the last one, nonlinear. Nonlinear would be a curved pattern. So we saw some parabolic curves, which means they looked like U's last week. So again, they were ones that look kind of like this if you connected all the dots. Today, we're looking at, unfortunately, this is the COVID death scatter plot from February of 2020 until April of 2020. So these are all points that were taken. And if we look at it, if we connected these, again, you couldn't draw a straight line to connect all these. It increases. This might not be the best job I've done here of creating it, but it curves as it goes up, right? So this is a curved relationship. And again, as time passed and we think about COVID, it's still an issue. The number of cases and the number of deaths skyrocketed, right? It started and there was barely any, and then it took huge jumps. So this would be an exponential pattern that would represent that. And again, yeah, time and COVID-19 deaths, unfortunately, would be a nonlinear relationship, and unfortunately is still increasing as we talk. So in summary, the line of best fit is the line that you would summarize the data set with. And again, you can have a positive correlation, a negative correlation, no correlation, or a nonlinear correlation, which could be a parabolic curve, a quadratic curve, an exponential curve. You could have a circle or something like that. It really depends, but those would all be nonlinear. All right, so when we pick our line of best fit, you want to follow the basic direction of the data. Again, it's not going to be perfect. You're not connecting the dots. You're trying to create a trend line. So where most of the data fits, that's the line you're going to pick. So you should have the same amount, relatively the same amount of points above the line and below the line. If all your points are below the line, your line's wrong. If all the points are above the line, your line is incorrect. You should have just about the same on both sides of your line of best fit. And again, you want to draw that line through as many points as possible. But you're not trying to connect all of the dots. You're not trying to draw your line through all of the dots. There will most likely be some below and above. So if we look at that first one again, to draw a line of best fit here, you should have an orange one I've already put next to it. Your job, again, just like we were doing last time, is just to tweak or turn the line. Once you move the line on here, you're going to move it up or down one of the sides to try and make it go through as many points. And then again, try and be equal with the amount above and below the line. So if I put my line here, if we said something like this, again, it looks like it's going through some of the points. You know, there's 1, 2, 3, 4, 5, maybe 6 below it, and 1, 2, 3, 4, 5, 6, 7-ish above it. So again, that's about the same above and below. So that's why this line is a good representation. Again, if you drew your line and you put it here and said it was going through a lot, if we look closely at this, all of the points are above it. So that wouldn't be a good line of best fit. And similarly, if we put it here, you know, most of those points are below it. So that would also not be a good line of best fit. And then another issue you might have is you don't want it to go like this. This doesn't necessarily make sense. Again, all those points. So again, you got to choose the right slope or steepness. You got to choose the right place to put your starting and ending points. So again, I would say something like this might be the perfect solution. There's about 6 points below, 6-ish points above, and it goes through a couple of the points there as well. So again, I'm not asking you to make this perfect. It's a line of best fit. So you're doing your best to try and make sure it goes through as many points as you can. All right, second one. So now we have time at the mall versus money remaining again. So again, the longer you spend, so this should be a negative correlation, should have a decreasing line. And again, you want about the same amount above and below. So again, if you look closely, you want to make sure your line is not something like this. That shows most of the points actually being above it. So take your time and draw the rest of these. I will put you in your breakout rooms and you can finish these up.